Hi, hello. We're still here. And this is still the great teacher Alcantara, and here with another video. And for this one, we're going to talk about word problems involving linear equations and two variables. The importance of this lesson is not only the skill in writing linear equations, but also understanding word problems, taking note of keywords in order for us to write the correct linear equations to solve the given word problems. So let's just jump right into it. Okay, for this one, we're going to start with our learning targets. We will be converting linear equations into variables to slope-intercept form, and the main focus is to solve word problems involving linear equations into variables through a variety of strategies. So we'll start with our word problems. Our first word problem is all about a certain river. So the first one is saying, suppose that the water level of a river is 34 feet and that it is receding at a rate of zero point 0.5 foot per day. Write an equation for the water level being y after x days. In how many ways will the water level be 26 feet? So we have here two questions or two things that we have to do. And the first thing that was indicated in our learning targets is that we would like our equations to be in slope intercept form. So the slope intercept form is written as y equal to mx plus b. Based on the word problem, we have indicated two things already. The water level is your y and the days will be x. Again, the y is your water level, and then for this one, your x will be the number of days. The only concern that we have now is to identify what will be our m or slope. What will represent the slope, and then what will be our y-intercept based on the word problem. So the m again is the slope, and then the b is gonna be our y-intercept. That's what we're looking for in order for us to write the correct linear equation representing the said situation. So again, it says here that suppose that the water level of a river is 34 feet and that it is receding at a rate of zero point 0.5 foot per day. So what you can notice here is that there's a mention of a rate that happens consecutively. So zero point 0.5 foot per day. This means that if something happens consistently for a certain situation, that could represent our slope. So in this given example, the slope is none other than zero point 0.5. Okay? And then the y-intercept is the one that we start with. Imagine the river and the height of that. So it's like the y-axis. If you draw a linear, I'm sorry, if you draw a Cartesian plane on that one, you can notice that the y-intercept represents 34 because that's where you start with. And that being said, our linear equation now will be y is equal to 0.5 x plus 34. But there's a concern here. Is your zero point 0.5 supposed to be positive? But the answer there is actually no, because the term is receding. When we say receding, this means decreasing. So that means that our zero point 0.5 should actually be negative. Again, the reason why it's negative zero point 0.5 is because the right term for it is receding, meaning it's decreasing zero point 0.5 foot per day. So that's our answer for the first one, in line with writing the equation. For us to answer, in how many days will the water level be 26 feet? Remember, the water level is y, and you're being asked when will it be 26. So what you will do is make water level, which is the y variable, equal to 26. So by substitution, you're going to have 26 is equal to negative 0.5x plus 34. So we will subtract 34 to both sides of the equation. in order for us to isolate the x variable. The reason that we want the x variable to be isolated so that we'll be able to get the number of days. Doing so, we're going to have negative 8 is equal to negative 0.5x. So to get the value of x, divide both by negative 0.5 so that we get the value of x, and that will give us 16 is equal to x, meaning it will take 16 days for the water level to reach 26 feet. So that's how it works. So all of the equations that we're going to do here are written in slope-intercept form. So we have to identify the slope and y-intercept as we move forward. So let's continue. Our next word problem is for babysitting. Nicole charges a flat fee of $3 plus $5 per hour. So we're again going to write a linear equation in the form of y is equal to mx plus b, where our y is the cost, or more appropriately, the salary, while the b here is again the y-intercept, and the x is for number of hours. So we have to identify our m and our y-intercept. So in here, if you notice in the word problem, there are two numbers that were mentioned, the $3 and the $5. Now, some of the mistakes that I've seen is that they make the $3 as the slope. The actual answer here is that 5 should be the slope. Why is 5 supposed to be the slope based on the word problem? Because 5 is the number that is consistently being multiplied to the situation. Since we treat x as per hour or hours, so the $5 should be multiplied to it as the hours increase. So that will be your slope. And the 3 is your y-intercept because that's the flat rate, the flat fee. That's where we start. The word flat fee implies that that's where we start, and wherever we go from there, it's either we increase or decrease. So in that case, our equation would be y is equal to 5x plus 3. So the question here is, how much money will she make if she babysits for 5 hours? So you will substitute that. Since hours is x, let x equal to 5. So y is equal to 5 times 5 plus 3. So the answer here will be 25 plus 3, and that will be 28. So she will be able to get $28 as her salary if she works for 5 hours. That will be it. To continue, let's have our next word problem. We have here a plumber that charges $25 for a service call plus $50 per hour of service. So we will write it again in slope-intercept form, y equal to mx plus b. Our y here again is the cost or the salary of our plumber. The x is our hours of service. So we have to identify the m, the slope, and the b, the y-intercept. So you can notice there's a pattern with the word problems in the way they're written. The terms per hour, since it's a constant rate of change, that's actually our slope. So you have your slope as 50, and as a service call, meaning this stays the same no matter what. It will not change. So $25 is our y-intercept. That's where we start with. Whether there's a work arranged or accepted or not, once you get the service call, you have to pay for that amount. So your equation here will be y equal to 50x plus 25. So you have two questions next. The first one is you make your x equal to 8 and the other x equal to 10. The reason behind this is because you want to figure out how much money or how much salary this plumber will get if he works for 8 hours, and then how about for 10 hours. Doing so, we will have y equal to 50 times 8 plus 25. 50 times 8, that is 400, plus 25, That will make this 425. On the other hand, if you have 10 hours instead, you'll have 50 times 10 plus 25. Y will be equal to 500 plus 25. 10 hours will give you $525 as a salary. So that's how it works. So we have here two different situations. What if you work 8 hours and what if you work 10 hours? Now let us go with our last word problem. This time around, we're not going to write just one word problem. We're going to write two in order for us to compare which is which. So the situation is as follow. Jim has to choose between two gym membership plans. Let X be each visit and Y be the total payment. So we have here plan A. So we already have Y and X settled. We have to go with what would be our what they call this, what would be our slope and what would be our y-intercept. Looking at plan A, it mentioned there that the $50 monthly membership fee and the $10 per visit. So just like earlier, the word per implies that we're going to have that consistently. So what we're going to have here as our slope is the $10 because that's what happens consistently, and we're going to add fee because that's where we start with. Similarly, for plan B, we're going to have 15x because that's the thing that you're supposed to be paying consistently. And similarly, we start with having 25. So the question is simple. Which plan will be much more budget friendly as the years go by? So you might think of it as a hypothetical term like the years. So we can make it as low as possible muna. So what we can think here, since at first sight, some situations will show you like, oh, this one's much better than that. This is actually a real life example wherein businesses presents certain kinds of plans, and the way that they present it is that this one is better in the beginning, but not all the time will it be better in the long run. So that's what we're trying to figure out here. So let's just say that this person decided to go for 10 visits or maybe even 12 visits. Let's just say 12 visits for both. And we will witness which is which in particular. In hindsight, you would think Plan A is a little bit expensive because of the membership fee compared to the $25 per monthly membership of Plan B. But if we do substitution, where X is visits, we can continue by having Y is equal to 10 times 12 plus 50. Your payment will become 120 plus 50, and that is equal to 170. While for plan B, you're gonna have y is equal to 15 times 12 plus 25. If you continue, this will give you 180. Am I correct with that? Is it 180? Wait, 30. Yeah, 180 plus 25. And as you can notice, it's actually much more expensive. This will be 205. So what makes a huge difference here is that um, the more that you visit this said gym, it will be much more friendly to choose the one with a higher membership fee. Sometimes it's how just things work in life, like the plans. Some things that you pay for expensively in the beginning will be cheaper or much more budget friendly in the long run. So you have to have options and you have to decide properly which one will benefit you better. Sometimes, it's much better to give or to take huge risks in the beginning and then enjoy later on than to enjoy firsthand and then suffer at the end or at the middle of it. I guess that's the way that I want this word problem to be interpreted because it's something that really happens or exists in real life. So that's it for word problems involving linear equations into variables. And that ends our video lesson for today. Please take note of all the skills, the techniques, and all of the details that you need to master in order for you to understand these concepts clearly. Some of these lessons you don't have to really memorize everything, but you just have to embody the skills, master it, practice it, and then with that, everything's gonna work well. And in case you don't see me, always remember, good morning. good afternoon, good evening, and good night. Peace out.